welcome to our next section where we go through solving quadratics by completing the square. So far we've talked about solving quadratics through graphing and as well as through factoring. So when we complete the square, basically we go through the same steps that we would have done previously in a previous section, and then we also have to go through the step of actually solving for x or solving for the variable, I should say, the polynomial of degree 2, as we start to figure out what the intercepts are. So when equations aren't easily factorable, we may need to complete the square to solve them. So my recommendation as we go through this is to jot down the questions, try each one out before you check out the answers, and then compare and see kind of how you do as we go through them, or if you get stuck, to be able to kind of check them off and see how you did. So let's get started. Number one, to solve by completing the square for the first part, we have our equation that's set up here. So we have y is equal to x squared minus 6x plus 4. And we'll walk through this first one together so you can kind of see the process and then kind of see how you do as we move forward. So the first thing that we're going to need to do when we complete our square is we're going to need to make our term 0. Now there's a lot happening in this first step. So remember, as we make our value 0, right, really we still have x squared minus 6x plus 4. Now also then remember that we need to group our first two terms together. We take half of the b value, which is 3, and square it, and that's where this plus 9 is coming from. Now remember, it's plus 9 and minus 9 inside of the brackets. The minus 9 is outside here because it just would have multiplied the 1 on that step. So our next step just has a couple of parts in it all together that we can kind of visualize and see. Okay, so really again, if I were to expand this out a little bit, we should see something that kind of looks like this inside the bracket, and then plus 4, and then because there's a 1 in the front, it's going to multiply the negative 9, and that's where the negative 9 comes from here. Okay, so just one step there. The next thing after that is to simplify. So remember, the b term that's here, half of that becomes the term that goes into the vertex form. So x minus 3 all squared, and then 4 minus 9 is minus 5. Now remember, we're making y 0 because we're trying to find out what x is. So from here, I want to take that 5 and move it over, and then we start to go through hopefully a familiar step now on how we solve for x. Okay, so I move 5 over to the other side, essentially adding 5 to both sides. Then, because it's squared, I'm going to need to take the square root of it to break that square. And so here's where I get that plus or minus from. Because remember, even if I take minus root 5 and square it, I'm going to get positive 5 back out. And so after that, we move the 3 over, and I get 3 plus or minus root 5 is equal to x. And then so from there, we can say that we have two possible answers, one for the plus and one for the minus, right? 3 plus root 5 and 3 minus root 5. And then we have this idea of approximate roots where they actually evaluate the square root of 5 and say, okay, 3 plus the root of 5 and 3 minus the root of 5 gives me 5.24 and 0.76. So we can come up with these approximate answers as well. Okay, so we go through our completing the square step first, and then after that we go through solving in vertex formed at 4x from there. All right, so here's our second question. I would like for you to try it out and see how you make out. So solve for x and try to determine what the roots are. All right, so hopefully you've had a chance to try this out. We're going to run through this question, and obviously if you got stuck along the way, to try to get to that point to understand if you got stuck, or if you're ready to check over the answer, to go through the step by step. So the first thing, remember, is to go through and to make y 0, and then after that we group our first two terms together and take half of the b value and square it and add and subtract it to the other side. And again, there's a lot that's happening in this first line. So really this first line should have kind of a line in between that we can fill in here, really where we have 0 is equal to, and then I'd have a 2 taken out. I'd have x squared minus 3 over 2x, 3 over 2x, and then we'd have that minus 1 outside. Okay, so that's where this 3 over 2 is coming from right there. Now, the 9 over 16, remember if I take half my b value and square it, half of 3, so 3 over 2, take half of that number, right, divide it by 2. That's basically like saying multiply it by 1/2. So really I'm getting 3 over 4, and then I need to square that value, and that gives me the 9 over 16, which is what we see here. Now, remember we're supposed to add and subtract 9 over 16, so really inside the bracket there would be a minus 9 over 16, but it got multiplied by the 2 and became 18 over 16 and already taken out of the bracket. So just a couple of steps there to kind of read through to understand where they came from. All right, but if you follow the completing the square steps, you will get to that point. Our next thing is to combine those denominators together. So we have, or to combine the minus 1 and the minus 18 over 16, so we need a common denominator. So minus 1, it would have a common denominator of 16 over 16. And so I'd have minus 16 over 16, minus 18 over 16, which would give me minus 34 over 16, like we see for our next step. If I take half the b value, then I get 3 over 4. And so that's why the 3 over 4 is inside the bracket for the next part. So from here, that's kind of our completing the square step. We would then add 34 over 16 to the other side. Okay, reducing the fraction down to 17 over 8. I would then divide by 2, and so remember dividing by 2 there is really going to make that 17 over 16 because we'd be adding or dividing it by 2 or multiplying it by half. So 17 over 16, because it's squared, that now means that this part gets square rooted. So we end up with root 17 over 16 is equal to x minus 3 over 4. Then now remember that really this square root, okay, the root here of 17 over 16 can really get broken apart into the root of 17 over the root of 16, which is really the root of 17 over 4. And so the square root can get broken apart into numerator and denominator spot. Okay, so plus or minus 17 over 4 is equal to x minus 3. Or sorry, x minus 3 over 4. Now I add over the 3 over 4 over to the other side, so 3 over 4 plus or minus root 17 over 4 equals x. So that gives me two separate answers because they share the same denominator. I combine the terms together and I get 3 plus root 17 over 4 and 3 minus root 17 over 4. So approximating it, we'd get 1.78 and negative 0.28. Alright, let's try out a couple other ones here. So we'll pause the video, give them each a try, and come back when you're ready to go over them. Alright, so for this one, we've got x plus 4 squared equals 9. Now, it's already set up in a form where we can solve for x. So remember, we're going to take the square root here of 9 to start off with. That's going to give me plus or minus 3. So x plus 4 is plus or minus 3. Okay, right there. Then if I move the 4 over to the other side, basically subtracting 4 from each side, that's where this negative 4 plus or minus 3 comes from. So really my answers here, negative 4 plus 3 would equal negative 1, and negative 4 minus 3 would equal negative 7, and I can see that here and here. Now, in the second one, I don't have that luxury of having a perfect square, so when I take the square root of that, I'm just going to get plus or minus 6. So x plus 1 is equal to plus or minus 6, whereas I can't break it down any further, so x is just equal to minus 1 plus root 6 and minus 1 minus root 6. And then I can evaluate them for specific coordinate points of 1.45, so the specific points here would be 1.45, 0, as well as negative 3.45, 0. Okay, we've got our next one. Let's pause the video and I'll get you to give it a try and come back when you're ready. Alright, so for our next one, we have y is equal to negative 3x squared minus 6x minus 1. So remember, we need to group together those first two terms, take out the 3. And so really what this is going to give us here, if I were to take out the 3, remember I'm solving for x, so y is going to be 0. I'm going to take out that 3, I'm going to have x squared minus 2. So basically, the b term gets divided by the a term when you factor out a. Okay, so x squared minus 2x, and then minus 1. Now I'm going to take half the b value, and I'm going to square it. So half of 2 is 1. And then we're going to add and subtract 1 inside the bracket, minus 1. Now remember, after that, in order to take out that minus 1, I need to multiply it by the 3 up front. So if I take a look at my next one, then we see that I have that x squared minus 2x plus 1, which I dropped right there, minus 2x plus 1. And then the minus 1 that's right here got multiplied by the 3, and that's why there's a minus 3 outside here. Okay, so next part, we go through and we have combining the outside term together. I took half of the b term, that's always what you have to do. So inside the bracket, this is half of b, that's why it's x minus 1 there, because half of 2 gives me the 1. And then minus 1 minus 3 more is minus 4. So after this, we go through the same solving steps. I move the 4 over to the other side. Divide by the a term. So the a term here is going to be 4 over 3, right? Divide by 3 is equal to x minus 1. And then I need to take the square root of this. So here I have the root of 4 over 3 is equal to x minus 1. Now, I run into a little bit of a problem here, because what I can do here is I can take, remember breaking this apart, this is the root of 4 over the root of 3. This is going to give me 2 over root 3. Okay, now the 2's fine, but remember that I can't have a rational expression in the denominator spot. It doesn't work well when evaluating terms, and so I need to rationalize that denominator, going back to radicals, in order for me to properly display what this is. So let's take a look and see kind of what this goes through. Okay, so plus or minus 2 over root 3 is equal to x minus 1. Now, move the 1 over, plus or minus 2 over root 3. I can't leave the radical as a denominator, and so in that case, I need to rationalize it, which is multiplying it by root 3 over root 3. Okay, rationalize that. Then I get 2 root 3 over 3 as my value left over. Okay, so remember that when we rationalize it, these two multiply each other. And so I have 3 by 3 makes 9, and root 9 is 3. Okay, so the x-intercepts are 2.16 and negative 0.16. Alright, so another example. I'll pause the video and let you give this a try, and then come back when you're ready to go over it. Alright, so in this case, what we have here is we have the same problem with squaring a term, so I need to square root both sides. I'm going to get plus or minus the square root of 9 over 8. Okay, now remember the square root of 9 over 8 is really root 9 over root 8. So the square root of 9 is nice, that's 3, but then I have the root 8 on the bottom. Now root 8 actually simplifies a little bit further. Remember that really 8 is just 4 times 2. So really this is just the root of 4 times 2, which is really 3 over 2 root 2. Right? Then I have the root 2 on the bottom that we need to go through and rationalize like we did in the previous problem. So here, there's my 3 over root 8, okay, the plus or minus from the square root term. Then minus 5 plus or minus 3 over root 8, where I cannot leave as a radical on the bottom. So I have root 8 over root 8, okay, rationalizing that expression. And then 3 root 8 over 8, and then keeping in mind that the root of 8 can really be broken down a little bit further. Now, this may look different from what I did above, but if I go through the same step here and rationalize this, root 2 over root 2, then we can see that I'm left with 3 root 2 over 2 root 4, and the square root of 4 is 2. So really this is 2 times 2, which is just 4 on the bottom. So I should see 3 root 2 over 4 pop up here. Okay, notice the next line here gives me 6 root 2 over 8 after rationalizing it and then reducing it down. So remember they did 3 root 8 is 3 root 4 times 2, which is just 3 times 2 root 2, which gives me that 6 root 2 over 8. And 6 over 8 reduces down to 3 over 4, which is what I have above. So my x-intercept here would be minus 5 plus 3 root 2 over 4, and minus 5 minus 3 root 2 over 4. So I have two different x-intercepts, negative 3.94 and negative 6.06. Okay, just as approximate values.